Hormone is two types. One is protein, one is steroid. Protein is a polar substance, so it cannot enter into the cell directly. So it makes a deal with an cell membrane receptors. It cannot go inside the cell, make contact with the intracellular receptors. Intracellular receptors are relatively slow compared to the cell membrane receptors. So protein hormones are makes and deals within cell membrane receptors because it is a polar substance. So cell membrane receptors also have a nucleogenic and non-nucleogenic. Non-nucleogenics are relatively fast. It waves an path to the emergency hormones. Emergency hormones like epinephrine, THS, ACTH. It acts through the GPCR. So because it it takes less time to restore the body. TSH needs a base. TSH is an emergency hormone. ACTH is an emergency hormone. So it should act fast. So it takes a path with GPCR receptors. It has another kind of receptor also, the non-nucleogenic. Non-nucleogenic receptors like tyrosine kinase, cytokine receptor, serine tyrosine kinase receptor. It acts relatively slow, not slow enough like intracellular, but it is relatively slow when compared to the non-nucleogenic like receptors, GPCR. It provides an hormone, the receptor tyrosine kinase like receptors provides an hormone to growth, local growth. Some kind of option is there. So we will see after that non-nucleogenic receptors. GPCR has three second messengers, increasing AMP, cyclic AMP, decreasing cyclic AMP, IP3 second messengers. Increasing cyclic AMP paves and way through that. It acts fast. It recovers body fast. So emergency hormone like epinephrine, TSH stimulate the GPCR receptor. GS subunit will increase the cyclic AMP and give that respective actions for the respective cells. Decreasing cyclic AMP, it exactly opposite to that increasing cyclic AMP. It acts through the GI subunits. Subunits stimulate, decrease the cyclic AMP, slow down that process. So hormones like somatostatins, epinephrine, like alpha 2 receptors are present in the presynaptic neurons. So it acts like a brake. It's exactly opposite to that, increasing cyclic AMP reactions. IP3 is, second messengers are stimulated by GQ subunit. GQ subunit increase the stimulate the IP3 second unit, second messenger. It increases the calcium content in the body. It is a non-rhythmic release of calcium ion. So it TRH, GHRH, oxytocin, alpha 1 subunit, acetylcholine, M1, M3, M5 receptors are active through that GQ subunit stimulate IP3 second messengers. And non-nucleogenic receptors like tyrosine kinase receptor, cytokine. If the hormone acts, if hormone wants a fast local rapid growth, it acts through that receptor tyrosine kinase. If the hormone wants sustained metabolic reaction, it acts through the cytokine receptors. like growth hormone. If the hormone acts, if hormone wants embryologically repair embryological and repair differentiation of the cells. If the hormone wants that action, means it acts through the serine tyrosine kinase. Hormones like TG beta activin embryological repair remodeling of the cells. So it serine tyrosine kinase gives the so TGF beta acts through the tyrosine kinase, get the resulted next we will see that steroid hormone bypass the cell membrane because it's a lipid substance is there. So intracellular receptor also there is two types, cytoplasmic receptors and nucleic receptors. Cytoplasmic receptors are estrogen receptors, progesterone receptor, androgen receptors, glucocorticoid receptors. There are so much receptor, like it is an important one. And nucleic receptors are tyrosine receptors, tyrosine not thyroid receptors, thyroid hormone acts through the nucleic receptors. Vitamin A, vitamin D, so it acts through the receptor. Steroid hormones are relatively slow because it stimulates the transcription factor in the nucleus, so it will take the time to give the desired result. That's all. This is the rough idea of the hormone mechanism of action. Yeah, that's it.